Hello again, guys. Uh, an even easier problem than the one that we solved before. The problem is asking that if you have this force, which is already given as a Cartesian, as a vector, and find the magnitude of the components F1 and F2 of this force that are parallel or perpendicular to that axis that we see over there. So the procedure is the same. You could try even to find this angle if you want to and then convert it like that, but don't complicate yourself with that trigonometry or geometry that is not easy, very easy to see to the untrained eye. And let's use, once again, magnitude of the components of F1 and F2. What is that asking you to do? Dot product. Dot product of what? Well, F1 goes in the line of action of OA, so the only thing that we have to do is find the unit vector in the direction of OA and dot multiply that with the force in Cartesian. That's it. Same thing that we have done before. So if I have to find the unit vector OA, it's not going to be any other thing than the coordinates of A minus the coordinates of O, which are 0, 0, 0, by the way. So this will be in X is this 3, in Y is 5, and in Z is negative 3. So 3i plus 5j minus 3k, and we divide that by this is OA, and this is equal to actually OA divided by the magnitude of OA. The magnitude of OA is the square root of 3 squared plus 5 squared plus 3 squared, and this is the unit vector. So if I know, I can multiply this, dot multiply this by the force, F, which is negative 40k, and the result of this will be just a scalar, and that scalar will give me the value that we are looking for. So I should put here the F dot dot. That's going to be the what is called here F1, which is basically the component of the force F in the direction. I don't like putting F1, but they say F1. Let me put it like that. F, the component of the force parallel to OA. Decompose in the direction, let me put parallel here to OA, in the direction of OA. So basically this is I don't have any I don't have any J, so the only thing is K, and that will be 3 times 40 is 120, 120 divided by this, 3 squared plus 5 squared plus 3 squared elevated to the 0.5. That will be the value of 18.3. 18.3 in the magnitude is pounds. So that will be the component parallel or in the direction of OA. For the component perpendicular, we do the same thing that we did before. We say that F squared is equal to F1 squared plus F2 squared, or if you will, F squared is going to be equal to the component of F parallel to OA square plus the component of F perpendicular to OA square. And we already have this, because the magnitude of this force is 40. So basically it will be, I pass this to the other side, 40 squared minus 18.3 squared, and I take square root on both sides. So I'm passing this, subtracting to the other side, and I get this, right? So that will be the perpendicular to OA, or that is called F2, is this, and then take square root of this, and take square root of that, and the force F2 will be 40 squared minus 18.3, which is the value that I have here square, and then I take the square root of that, and that will be 35.57. 35.57 pounds. That will be F2, which you can call it also as the component of F perpendicular to OA. Whatever notation you like, that will be the answer for this problem. Another easy problem. Of course, easy if you know what to do and when to do it. What is the key here? Once again, find magnitudes of the components directed along something. Dot product. That's what they're telling you. Dot multiply the force and the unit vector of the direction that you are looking for. Thank you for watching, guys.